Okay.
I was asked by Christopher if I could do sort of a talk on a bit on architecture and a bit on stuff relevant for the graphics exam.
Yep.
So prepared slides, you know, yesterday. So let's see how this goes. We're going to cover a bit different topics. So I'm going to start with talking about game object systems. So the motivation for Christopher asking me was that apparently some of you have asked me stuff before and for the different exercises, and we thought it could be cool to also bring it up with the rest of the class.
Yeah.
I'm first going to cover game object systems. So sort of how you can structure your game logic code, and show you basically an object-oriented system, a component system, and quickly discuss entity component systems, and then discuss the number one problem, or at least the thing I always find difficult when making those systems, which is communicating between them. And then I'm going to show off the graphics exam that we had, or I had, that I created with a bunch of other students, and the framework that we started with. And then, well, not the RAII stage wrapper, because that comes after discussing quickly like how I went about optimizing my graphics exam sort of after the exam was over. And then I guess one tip thing is I'm always going to cover the first tip earlier in the talk. So game object systems. There's many different approaches to doing this. So we're not talking about, let's say you're doing your Pac-Man game. We're talking about how do you actually model Pac-Man and the different attributes that exist within Pac-Man. I've seen a bunch of you go with the put everything in one class, or so you have or a more object-oriented inheritance-based model. So you have like an entity class that everything that Pac-Man inherits from, or that Ghost inherits from. So how many is it that have taken that approach with the Pac-Man game?
2D Pac-Man, yes.
Yeah. So that's obviously one solution. It usually works for smaller projects. As you'll see in my graphics exam, we actually did that for our game logic there, sitting as there wasn't really that much game logic. You can do the inheritance approach, everything inside of sort of like a game object base class, and then you can have subclasses like a drawable game object, an AI controlled game object, and a physics game object. But you sort of can quickly come into the problem that you end up in situations where sort of your inheritance tree doesn't sort of map out anymore. You don't know how you can adapt to changes. These things are sort of always difficult to explain, so I thought I could just jump straight to an example. So here's just sort of a simple game that I created yesterday, just to show this off. So we have these small balls, or these small circles. Some of them move around, and then you as a player is the square, and then you can eat them. And you're supposed to eat as many as possible between in 20 seconds. Yeah, so I got 19 points. 15. And I was trying to sort of keep it simple so that there's not that much code. And obviously this solution is way overly complicated for the problem at hand, obviously. But I sort of wanted to show one way of modeling this if it were sort of a bigger thing that happened. So I just used SFML for this rather than OpenGL because I didn't have that much time. So at the top of our hierarchy, we have our game object. Also, the different objects that we have running here is that we have a game object, and then we need something, and the game object is a square, and then we need something that sort of is edible. So we have an edible object, and then we need something that is edible and moves. and so that's the movable edible objects. And then all of the edible objects can change color, so they so we have sort of that represented there as well. So we have our top game object object, which has sort of a virtual update function that everyone can overload if they need to, and they have the possibility of setting its position, because everything has to have a position in this way. And then our square has a radius, and that's just because I'm sort of doing circle hit detection even for squares, so just ignore that for the moment. So yeah, so we have our square shapes, which inherits from a game object. Then after that again we have our player, which inherits from a square shape, seeing that a player is a shape and a square shape is a game object. So we're sort of doing the ISA modulation. And then, so that's the player done. Essentially, the square shape has its draw function, which draws a square, and then the player has an update function, which like does controller checking, etc. And it also keeps track of the score, so controller and score. And then we have our circle shape, which is where we start with sort of the edible line of thinking. So we have a circle shape, which is the circle shape, overloads the draw mechanism. From that again we get the random colorable object that inherits from the circle shape, because this is a circle shape that we want to assign a random color. So they update their color in the update function, and then they also overload the draw function to change the color of the object. And then lastly, we have the edible, or not lastly, second to lastly, we have the edible, which obviously is a random colorable object, because it will be updated with random colors. And then they have their is-eaten function, just so that we can check if they're currently colliding, and in that case update the score, etc. And then moving collidable, or moving edible, which is basically the same as the edible one, so it inherits from the edible. The difference here is that this one can move around, so it does that with the update function as well. So that's sort of like a simple inheritance tree, just so I could sort of get across the problems that we are facing with just this simple stuff. Which is, if I want to make a square editable, how would I go about doing that?
You'd have to make another branch.
Yeah.
More branch.
Make the tree more shallow and then have multiple
Inheritance, yeah, except multiple inheritance is often shied away from for different reasons. Because you can quickly get into stuff like diamond problems, etc., or multiple instances of the same variable if you share the same base class. So you can sort of get the same variable twice, if I don't remember wrong. But that's one possible, yeah. Also, what if we say that we're working in like a couple of years ago, when sort of like PlayStation 2 errors, which I guess is more than a couple of years ago, when you go into GameStop or whatever, and then they would have a game playing on a screen, and then that screen would always, or the games would have demo modes essentially. And one of the reasons for having the demo modes was that you had to ensure that you wouldn't get screen burning at either people's homes or in the shops.
Screen burning?
Yeah, like if a picture was on the TV for too long, or static images was on the TV for too long, then the image would actually sort of like burn into the TV, so you see the sort of watermark from it.
Yeah, that's why it has to move.
Yeah, that's why that's one of the reasons for having the demo modes. So if we want to create that, the most sort of logical thing to do would be to have an AI control the player. That's not necessarily really easy now, because the player is controlled by the game logic, or no, I mean, is controlled by the keyboard controller, and that's sort of embedded into the player class. Which means that we either need to add another function to rewrite that code, or we need to do different stuff. It's sort of like it's a bunch of work. Or I guess the most relevant example is, say that you guys are doing a graphics assignment, and then you have written a functional sort of graphics component or graphics part. And then you want to update that, you want to change the implementation. However, you're not sure if it's actually going to work. So you sort of just want to test it. And then you sort of go, okay, well, if I'm going to do these changes, I could have to do them sort of like inside the class. So I have to probably modify the already existing implementation. It's unless you're using like version control to fix that, which is obviously a smart thing to do. But you don't necessarily want to like branch out to try and fix that problem and modify the existing solution. It would be better to have some way of just hop and swap different aspects of the sort of logic into different classes, if that makes sense. And with that comes, you know, with that comes components, which is essentially that, yeah, we want to avoid the inheritance that one blocks out the sum, because it's usually fragile and it's not really like accepting towards changes. And we want to add, instead of thinking of sort of like is there a relationship, we want to think in a more behavioral relationship, so that, you know, you're adding behavior to something, you're not saying what it is. It's an object is comprised, or sort of a game object is more comprised of the behavior it has rather than what it inherits from. Essentially what we do is that we use components to encapsulate different behaviors, and then we just attach a component to our game object / entity. And then to show off how easy, or show off a simple component system, I created a demo of the same game with minor differences, using our component systems instead. So the main difference now is that everything isn't randomly colored when we start up, and has different sizes. So essentially what we're doing here is that we have a simple component interface, sort of an I component, which all components should inherit from this, just so that and it supplies an empty draw function that everyone can update, and it supplies an empty update function that everyone can override. The only thing that we're requiring for this implementation, there's a bunch of different ways you can do this, obviously. For this implementation, we're requiring that we specify what type you are, just so that we can potentially get components out of a game object. And then our game object is relatively simple. It's essentially, in our case, or in my case, it has a position. I'm requiring everything to have a position, and then I'm also requiring everything to have a radius for the hitbox detection, which could also have been pulled out into its own components if you want to do that. And then it just has a vector of pointers to different components. And then essentially in its constructor, it takes sort of the position and the starting position and the radius, and then it takes all the different components in the constructor. And then in the sort of its updates and draw function, it just goes through everything and calls up the update function, where it passes in itself as an argument. I'll show off that afterwards. And then in the draw, it's sort of the same thing. So now we have, and then you have the possibility of sort of getting a component out of this as well, so you can go through and search for a specific type of component.
It sends itself.
Yeah. I'll come back to it. And then, yeah, we have the radius and position part. But as you can see, this is a relatively simple sort of game object. It doesn't do much. It just has the update and draw function mainly, and get components. That's the only functions that we actually need in this case. So then the question comes, like, what are these different components that we attach to it to give it its behavior? And in this case, we're sort of still basing on myself on the aspects that I saw in my inheritance-based approach. So we still have a square shape, which is the rectangle shape. And in this draw function, and this is sort of where you see why we're passing in the game object, is that we get the radius from it, and then we shit example. But we'll take one of the other components instead. But it overloads the draw function, gets the game object and the window that's supposed to render to. And then if we go to the keyboard, the random, So essentially all the other components have the same logic, like the way we inherited their logic and overloaded their different super functions in our inheritance-based approach. All that logic is exactly the same here. So we don't have to change any gameplay code directly, or most of the logic at least. And then if we go down to the random colorable, so the random colorable one is the only one where we sort of get into a bit of problems, because this is the only place where we actually use the other game components. So seeing as we want to update the graphics component, we need to actually get it, which is why we're sending in the game objects. So in this case, we're doing it in our init function, but we could also have done it in the update. Because I need to, as a random colorable component, I need to get access to the graphics component so that I can change its color. And in this case, we just sort of get it by asking the game object to get it. And then in our update function, we update the color and do hilariously ugly casting to do that. But that's one way of and in this case, we just updated it, so sort of this should show how easy it is to add these components together. And the same one with that's actually the only one that needs the component, I think. And then we have the edible component as well. So we have removed actually the movable edible component, or not component, the game object that we had in the inheritance-based approach, because we don't need it anymore. Because we already have sort of a random movable component that we can attach. And because we have that, we can say that an edible component, or a movable edible game object, is just a component that has, in our case, sort of it has its graphic shape, and it has its random movable component. And we also added in a wall collider component, and it has to change its color randomly. So it also has the random colorable component, and then it's edible. And that's it. And then we started at the random position. So basically we start just doing a bunch of these make functions for creating different game objects. So say that I would want to do any of the previous sort of challenges, say that instead of, or adding the AI for the demo example, doing that is sort of as simple as instead of sending the keyboard controller, we send in a random movable or another AI component. Or if we want to change that it's not a square anymore, we want it to be sort of a circle instead, then we just turn the circle shape. And now suddenly that's random movable. And then the random movable obviously needs some input parameters. So we'll just do that. And hopefully now it builds. Ooh. And now I think that's the game object, which and then it starts moving around and hopefully crashes into something. Yes.
So why are you using make functions instead of doing it in the constructor?
Because if I'm doing it in the constructor, then I suddenly have to start creating a player class again.
So it's just the game object still.
It's just the game object. Everything is just the game object. There's no player class.
The game object, and then you make classes for the components, and then you say the game object, you just have a vector of references to classes.
So there is no if you look down into my main code, there actually isn't any, sure there's a player variable down here, but there isn't any player class. Because the player variable is still a game object, it's just that it has different components than all the other ones. Which means that if you need to add a new sort of variation on something, that's super easy. Just create a new function that or you don't need to create a new function, but you usually quickly end up doing that because it's easier or more readable to add in functions. But just create a new variation where you add in some different components based on the behavior that you need.
So you're using a vector. How were you like getting out a specific component if you didn't have a key? Because I imagine that the component type would be the key, and you would map every single one of the references to objects, like the components, to a specific key.
Yeah, and I am doing that.
Oh,
so the component type is sort of the key. In this system, I'm not allowing you to have multiple instances of the same component within a game object, so we can't have two circle shapes. And then I require that every component has to inherit from the I component, which is stupid that it's called I because it's not like a pure virtual interface, but anyhow. It has to inherit from that, and that supplies like a way to get the component. So in the game object, we just do a linear search for all the components and check if anyone has the type that I'm asking for, and if they don't, then we return a null pointer.
Yeah.
Which means that you can also, that's sort of also what Unity does when they, because you end up in the problem like, what if you aim for a component, what if you have two components that sort of require each other, and then in this case, I'm just saying, well, in that case we crash just with the reference of the null pointer, but for instance, like Unity does is that it allows you to like specify that this component requires another component, etc. And you could build in like a search to do that for you.
So then adding a demo mode would be, like you could even do that as a compile parameter, where you just, well, you define this is the demo version, and if demo version, then you have you set a player like AI movable instead of like a controller.
Yeah. But it's not necessarily cool to do it as a compiler thing if you want your game to be able to switch into that if you're waiting in the start menu for too long. But then that's the other possibility, yeah. So the point is that it's just like going back to this being a square shape. This is essentially the AI mode, or sort of like the demo mode, just switching those two.
This also makes it easier to change behavior during runtime.
Yeah.
Because
you can literally just have a pool.
And you can also change the behavior which you didn't
think about
statically specify.
Yeah.
You don't have to
write
new classes for new behavior.
Yeah.
Because you can just mix it in different ways.
You just need to add classes or you just need to add sort of components to introduce new behavior into the system. But if you can create new behavior from existing components, then it's just sort of like a Lego mix and match.
Yeah, because earlier you actually needed new classes for combinations of components, but now you only need new for single components. Yeah, but combinations will just figure itself out. You could figure them out after.
Is there cases where you need to consider the order of execution for components?
That's sort of the next next problem that I will get to.
Right.
Because that is a problem.
Right.
But yeah, everyone is sort of understanding how this functions or how this works. The concept of it. Yeah. Because there is this one is still purely object oriented. It's sort of just like we just changed the aggregation approach. And I would say also sort of like. This also solves the problem that I said about the graphics part. If you have a graphics component and you want to create a new implementation and you don't want to potentially destroy the old one, then sort of just adding a new component that is like graphics, V2 or whatever, and then develop that and test it, and once you finish it, you just go like, okay, instead of having graphics V1, then we'll do like graphics V2 for the components, etc. So you can like develop stuff in isolation and just attach it later. The only thing that you're sort of requiring is that you fulfill the the iComponent interface. But yeah, as I said, this component, this is a really simple way of doing it, and it gets the job done. There are some problems here. So for instance, you sort of get into the issue that even though we actually just have two types of circle shapes, or two types of things that can actually be drawn, I'm still going through and doing empty draw calls on all the objects that doesn't necessarily have that function, which isn't, you know, super great, but it's it makes it easy to test really fast. But that's sort of considerations you have to do if you want to take, like how, in which way do you want to take this. And this one is really easily extendable, and doing those sort of empty virtual functions won't necessarily be what, it probably won't be what kills your system. And then, so for instance, I also added the init function, and that's specifically added just so if I need to get other components, so like the random colorable, which needed the graphics component, you could either get that sort of in update, but in that case you're doing like linear searches every frame, and that's not necessarily smart. So you could use that to like set up your all your references and getting all the components you need. Which sort of means that you can't, these objects often start depending on each other. So, you know, the game objects needs the components, and often the components needs the game objects. So you're sort of getting to the problem like which should be created first. Is something you can quickly get into. And the way I usually solve that is, or have solved it in this case, is that you take all the components in the constructor, and then in the constructor, the game object calls an initialize function to sort of like finalize the construction within its constructor, so that everyone can set up all the references they need, etc.
Which constructor?
In the game object constructor. So you see here I'm doing the like init.
So everyone first runs their constructor and then everyone runs their init?
Yeah. Because I have to, seeing as this game object takes the components in as an input parameter to its constructor, then they would have to be constructed before that. But as I said, there's different ways of doing that. So yeah, this one is still fairly object-oriented. There is, but doing it that way is sort of what I would suggest for an exam or something. Because there is one more, like you can do this really, really heavily, which is where you sort of double down on the components part, which is when you start sort of entering the entity component systems pattern. And that's where you don't have a game object anymore. You just have a bunch of components, and then they share some sort of attributes that makes it possible to link them together, usually an ID. So you can say like, okay, I don't have a game object anymore. I just have a bunch of components that has the ID of like one, and that defines one game object.
A global list of components that all the entities in the world uses, but they all check for their ID in the list, so they all go to the list every time to find all their components?
No, usually you wouldn't implement it that way because it would be really slow.
Yeah.
But essentially yes, because you find different ways of doing the searching faster. So
no, please continue on.
So one example would be that the simplest way of doing this, which also wastes a lot of space, is that the ID of a game object is also their index in the global array. So if I'm sort of ID 0 and I have a component, a sort of graphics component, then that is also at position 0 in the graphics components container.
But then again, you can only have one of each.
Yeah. But you can fix that by saying that you can have a sibling component, which has a link to another ID, and that's in that case you sort of end a bit more with a relational database approach. Yes.
An advantage of that would be that you don't have to store the ID anywhere because it's implicit.
No, you have to store the ID in all the different components.
No, because it's implicit. You can.
Yeah, in the
if
index.
you know your own index.
Yeah.
You know that every index 0 in every other component system is.
But the problem that you need to sort of fix there, which is how do you not waste memory? Because if I don't have that component, then you still have to have room for it.
0 or empty space. Yeah.
So there's a bunch of different ways of doing this, and all of them are all of them have their different challenges. I would say for an exam, like for your exam, unless you've done this before, don't do this for your exam. Do the previous one I talked about, because we wrote our bachelor thesis doing this. Or at least part of it was just creating a system like this. But it has a bunch of really super cool attributes if you actually get it to work. If you actually get it to work, it's super fast. And if you can figure out a way of knowing communication between the components, how they communicate with each other, and you can isolate that, then you can run stuff in parallel. So if you know I know that my random movable component and my random color changer component, they don't need to communicate at all, and they don't modify and they're the same state. In that case, we can just update both of those in parallel. Just give a thread to each of them, and then get to work.
Yes. You were talking about the complexity of having entity-component systems and their interactions amongst them, right? Links amongst them. Aren't you breaking any concept of abstraction there, because they know about their mutual internals to some extent, right?
To a certain degree, but if a lot of the people who write this have that go, or some of the people who write this system that go real hardcore into them, they don't actually consider them objects anymore. So you sort of they move over to have you just have data and functionality, and then that's sort of where the entity component system, and there the focus is actually on the system or systems, which is you have your entities, which is the IDs, and then you have your components, which is pure data, so just structs. And then you have your systems, which is a class that is the physics systems. And then you just feed all the components, which is pure data, into that, and then it updates what it needs to update, and then it goes out. But yeah, you can quickly get into sort of the problem. In the previous system, that's not as bad, but yeah.
Just thinking about, because now I was just reflecting. Okay, which system shouldn't be built this way, right? So where can you make explicit? Where's the decision-making point where you suggest, okay, actually go for conventional object orientation with all its flaws and so on, or as opposed to component system, right? So when to find this trade-off, it would be interesting really where where it completely falls over, no? So that would be the question. And the intuition was that if you have too much, require too much introspection into other components, you're breaking abstraction, therefore your system will not be maintainable in the long run, right? So that would be the intuition.
But often each of these systems are also completely independent. Like say if I have a physics component, that doesn't need to know about the graphics component. However, the physics system needs to know about all the, need to know everything about the physics component. Right. But that's sort of also expected. You wouldn't have a physics system that doesn't know how the physics components work. Also sort of when should you choose this? From what I've seen, you usually choose this for your game object code, and that usually turns into a mess of that anyway, because you have to iterate so much, and again, games being short and not needing to be supported for 100,000 years, most of them at least, so you don't necessarily have that problem. Because it's worse in the other way if you're doing a super inheritance-based approach, and then suddenly you're deciding take the Unreal Tournament. There's a missile there that you can fire and sort of move. That's way easier to do in a system like this than in an inheritance-based system. So it's sort of this easier accepts changes to a certain degree. Yes.
I also think that we don't know
how many things this can be applied to, because it's an idea which has like grown out of graphics, low-level graphics people.
Well, more game logic, I think.
Yeah.
Because that's the most natural place of using it.
Yeah, but in that area, in that niche, sort of, and it hasn't been widely explored for other cases yet.
Yeah.
Sort of. Yeah.
But essentially, if you think about it, what this essentially does is that, you know, if you're making a particle system, you would never model each individual particle. You would always model them as a pool, and then you start sharing the implementation of the system to everyone outside. If you want to like activate one particle, etc., and you. I don't know where I was going with that analogy.
But I get that you want to isolate the functionality to some extent and put it into components, and you can easily compose it and change the composition afterwards.
But I mean, technically, every component, while you might, like, you will know of the interface of the other components, so you will be able to call functions of them, but you still have the possibility of making stuff private, etc. But each component will contain all its logic individually. Because, so you get that benefit of sort of encapsulation. But yeah, and then comes the like biggest problem, which is how the hell do we make these things talk? And that comes into the what you said as well. It isn't trivial. It's actually one of the things I find to be hardest to solve. There are different solutions to this. You could just like I did in the system I showed up, you can just update the game object variables sort of like in component functions. The question is how, if you have dependencies between the components, or there's some sort of, you have dependencies. Like in this case, we have many components that needed to update the position of the game object. In this case, I solved that by giving a link to a game object in the update function of the component so that they could always get access to the game object. The problem with that is that there might be situations where you can't change the update order. So if you sort of get interdependencies, then you know, stuff doesn't work necessarily that way. I don't consider that a huge problem, because looking at some of the game engines I've read about, they usually have very explicit update orders in sort of their main function. There isn't like the update loop that we often go for, which is that everything has an update. It more goes like, now we're running the pre-animation update, now we're running this update, now we're pulling events from this system, now we're... So sort of you have to be, or you might have to be that explicit about it. I'm guessing everyone sort of has this different approaches, but that's the one I've seen that at least makes most sense to me. And then, the problem is there, the communication is sort of implicit. And you're, if you need to, the problem comes if you need to add sort of like more state up into the game object. So now we have the position and radius, and if we suddenly need the color as well, then we might move that up to the game object. But then you're moving way more back to the object-oriented approach. Or you can have direct references, which is what I did for the random movable components, which is that you have the init function, and then I get the random reference, or I get a pointer to the components that I will use. This deals with like inter-component communication. The main problem with that is if you're using pointers, you cannot move those components around, which you might want to do. So that sort of that might then start coupling your component references to the implementation of the way you're getting your components, which is why I would suggest that if you have the possibility, don't do this with pointers. Instead of having like a pointer to, this is especially if you're making a more complicated system, don't have a pointer to a component, have an ID or index for it so that you can go and look it up potentially, because if you're doing the pointers, then you can't move in memory, and if you have I'll get back to that.
Or tags.
Or tags. Yeah. The next one, which is the most complicated one of them, is doing message passing, and that's like building an event queue or message queue or whatever. I would say to keep it easy, I would sort of stay towards the upper parts of this. So have going with the direct references. That's the one I consider to be the easiest one. And then you guys probably won't get into the problem of like having so many game objects that you get a memory issue. Because one of the issues is if you're doing the pointers thingy and you are just randomly allocating those on the heap with new and delete, suddenly your memory starts looking like this, which isn't really cool for your CPU. So alternative is that you just store everything in sort of arrays, and then you point into those arrays, or in vectors, and then you don't point into the vectors because that will resize. So then you can use indexes instead. However, I would still suggest, like, this is a problem that you probably won't have to think about. So suggest that unless you gain more experience, go with this one. This, like, doing it that way isn't actually that big of a problem for the scope that you guys are dealing with. Yeah.
We're thinking about having references to other components as members.
Yeah, and then set them in an init function. Because then you don't have to search every time. So that's components and communication between them. Is there any questions or more questions to that?
Are there any frameworks for message passing that are commonly used? I mean, in let's say the game engine you explored, because it's an interesting problem and challenging at that. But I'm just wondering if you know how efficient that would be. You know, if you imagine you introducing a message passing mechanism within a game loop, that could be quite a performance impediment.
Can you first quickly explain what the messaging system actually is like? What does it do differently than just sending stuff?
You could have that. I'll take that question first.
Of course.
So what you could do is that for the messenger one, there's different ways of doing that again. One thing you can do is that you say that to the game object has sort of like void send message, and then inside that you send a message object, and then it goes through each component, and then it calls like item receive message, and then this one has like a virtual void receive. And then it can choose to react on the message or not. That's
so it has like a static vector or something of messages, and each have like a destination. So you say, okay, so this message is for who with what data?
That's a more complicated way of doing it. Yes.
Okay.
This is the easiest way, but also that this way of sending messages gets to the problem that it's hard to send messages to other objects, and then also this one happens sort of like here you also get interdependency problems if you're doing this in the update loop, because then if I have an object that really wants to get this message and react to it, and that should sort of have influenced its update, then that won't happen until the next frame if it has already gone before in the message loop. So this is just like all of these are problems. That's one way of doing it. Another way of doing it is that you have sort of like a global event queue, which follows follows a pattern that you said, that you just have a queue, and then you have the ID that you're sending something to, and then the message. And then at different points in time during the game loop, you sort of go through and separate out all the messages.
There's like a route to the
Yeah. Yeah. That's and from what I've seen, usually you end up going with all of these systems at the same time. So you have like the global event system, for instance, when you're sending out stuff that the whole world should know about and other components interact to. But if you're just sending messages that are only relevant per your game object, then you might send them through this, send them this way. In other parts, maybe there's sort of shared state in the game object, so you just go and update that directly. So like all of these have different trade-off in their complexity and efficiency and all of those. Like everything is trade-offs. When it comes to like existing frameworks,
you thread messaging. Can you just fork and check if you're the child, maybe the child will deliver messages, and if not, you continue to update.
Sorry, I didn't get.
Could you multi-thread the messaging?
Yeah, we did that in our case because every I'm just thinking how we actually did this. Yeah, we basically multi-threaded the delivery of the message to the different components, so that we essentially pop the message off the queue, sort of, and then we had each thread sort of went and updated one component with that message, and then another went and updated another one, if the user could indicate that that would be a thread safe thing to do.
Right.
Yeah.
Right. A lot of assumptions there, right?
Well, our system was opt-in, so if the user didn't specify anything, then we would always assume that there would be a race condition if we tried to update that.
Very nice.
So essentially, when they sort of registered the different components, they had the possibility of saying like, yeah, this component only reads from this data, and then we would use that information to find a way to layer everything so that they would run. The stuff that wouldn't have a possibility of sort of getting in the way of each other, they would be run different layers. So we could sort of always have a thread safe layer, and then at the end we just run everything that we didn't know anything about in one thread. But yeah, so that's the this is
Do you want to have a break for a second?
Yeah. If you want to know more about this, then check the game programming patterns. It covers it in the component chapter and also in the data locality and object pool chapters.
Best chapters.
Best chapters, the one on optimization patterns.